good afternoon, good morning, good evening, depending on the time that you are watching me from. I'm Teacher Jason from Potent Academy, and we are here doing chemistry with my form. This is chemistry. So the topic that we are going to do, it's called the mole. The mole. The mole concept is a topic in Form 3 amongst other topics. For example, the first topic is called the gaseous. The second topic is the mole. The third topic is nitrogen and its compound. The fourth topic is sulfur and its compound. And finally, the fifth topic is chlorine and its compounds. So, we start by asking ourselves, what is a mole? What is a mole? What is a mole? A mole is the amount of substance that contains the Avogadro's number of particles. So there are very many ways we can define the term mole, but this is the best way of defining what a mole is. A mole is the amount of substances that contains the Avogadro's number of particles. Now a question comes, which particles are these? Which particles are these? The particles can be ions, atoms, electrons, protons, neutrons, and so on and so forth. So all these ones are particles. Ions, atoms, electrons, protons, neutrons, radicals. All those ones are particles. Another question comes, what do we mean when we say the Avogadro's number of particles? The Avogadro's number of particles are the number of particles that are there in 1 mole of a substance. And the Avogadro's number of particles are denoted as L. Can you see L? They are denoted as capital L. And the Avogadro's number of particles are 6.023 times 10 to the power 23. That is what we call the Avogadro's number of particles. That is what we call the Avogadro's number of particles. That is what we call the Avogadro's number of particles. Now let's now move on to the interconversion of moles. 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 Interconversion of moles entails converting moles into mass and converting mass into moles. And what is the relationship between mass and moles? Mass, or the number of moles is given by mass all over RFM. That is the relationship. The number of moles is given by mass all over RFM. So the units for calculating the number of moles are moles. Remember, when it comes to the mole concept, the units are very much important. The units for calculating the number of moles are moles. The units for calculating the mass are grams. The units for calculating the mass are grams. So here we talk about mass in grams. We talk about mass in grams. What about the units for calculating the RFM? When calculating the RFM, we put no units. Yes. What about the other names for RFM? RFM can be called relative formula mass. RFM can also be called relative molecular mass. RFM can be called relative atomic mass. RFM can also be called molar mass. All these names refer to one and the same thing. All these names refer to one and the same things. So the RFM for the elementary elements, one, you have sodium. Sodium has an RFM of what? Of 23. Carbon has an RFM of what? 12. Hydrogen has an RFM of 1. Oxygen has an RFM of 16. Which other? Sulfur has an RFM of 32. What about iron? 56. What about magnesium? 24. Sodium 23, carbon 12, hydrogen 1, oxygen 16, sulfur 32, iron 56, magnesium 24, calcium 40. Calcium 40. Then, yeah. For instance, let's do an example. Let's do an example in calculation. Let us calculate the RFM of sodium hydroxide. Let us calculate the RFM of sodium hydroxide. Sodium hydroxide. The RFM of sodium is 23. The RFM of oxygen is 16. The RFM of hydrogen is 1. We get a total of 40. Are you getting 40 using your calculator? 23 plus 16 plus 1 is equals to 40. Is equals to 40. Let us also calculate the RFM of sulfuric 6 acid. The chemical symbol for the chemical formula for sulfuric 6 acid is H2SO4. What is the RFM of hydrogen? 1. How many atoms of hydrogen do we have? 2. Multiplied by 2. Plus, what is the RFM of sulfur? 32. What is the RFM of oxygen? 16. How many atoms of oxygen do we have? 4 of them. When you key in all these values using your calculator, we're getting your answer as 98. Are you getting your answer as 98? Yes, the answer is supposed to be 98. 2 plus 32 plus 16 times 4, the answer is equals to 98. Let us now calculate the RFM of ammonia. Ammonia is NH3. Ammonia is NH3. Therefore, nitrogen, the RFM of nitrogen is 14. The RFM of nitrogen is 14. The RFM of hydrogen is 1. How many atoms of hydrogen do we have? 3 of them. We multiply by 3. The answer will be 14 plus 3, 17. Therefore, the RFM of ammonia is 17. What about ammonium chloride? This is how we write ammonium chloride. Ammonium chloride. RFM of nitrogen is coming to 14. The RFM of hydrogen is 1. How many atoms of hydrogen do we have? We have 4 of them. What about the RFM of chlorine? RFM of chlorine is 35.5. So we add 35.5. So using your calculator, you key in all these values. 14 plus 4, get your answer as 18. 35.5 plus 18, get your answer as 5, 3, 5. 5, that is 13, you carry 1, 5. Therefore, the RFM is 53.5. So, solving calculations relating with RFM is as simple as that. And as you have observed, there are no units when we are calculating the RFM. We talk of 40, 98, 17, 53.5. 53.5. Very fast, help me calculate the RFM of carbon dioxide and water. Help me calculate the RFM of carbon dioxide and water. So, carbon dioxide we write it as CO2. Can you see how we write carbon dioxide? Our C is capital, our O is capital. RFM for carbon is 12. RFM for oxygen is 16. How many atoms? 2. We get your answer as 44 after adding up. Let us calculate the RFM of water. Hydrogen is 1. You multiply by 2 because the atoms of hydrogen are 2. Then you add 16. Get your answer as 2 plus 16, 18. Therefore, the RFM of hydrogen is 18. I think those examples are enough. Let us now enter to the interconversion of moles. Using which formula? This one. Number of moles is given by mass all over RFM. Do this question with me. Do this question with me. Part A. Calculate the number of moles of 0.1 grams of sodium hydroxide. Calculate the number of moles of 0.1 grams of sodium hydroxide. How do we do it? We first of all write the formula. The formula is number of moles is given by mass all over RFM. Are we given the mass? Yes, we are given the mass, and the mass is 0.1. Are we given the RFM? No, we are not given the RFM, but we can calculate. We are not given the RFM, but we can calculate. We are not given the RFM, but we can calculate. So, the formula of sodium hydroxide is sodium hydroxide. Sodium is 23, oxygen is 16, hydrogen is 1. Therefore, 0.1 all over 40 is the number of moles. There's a number of moles. So using your calculator, key in these values, 0.1 all over 40. And you can comment down there below. Tell me the answer that you have gotten after dividing 0.1 divided by 40. That's how we solve that calculation. Now we enter to another one, another example. We do another example. We do another example on interconversion of moles. 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 Another example is B. Calculate the mass. Calculate the mass of the following chemical substances. Calculate the mass of the following chemical substances. Part 1, 0.01 moles of hydrogen chloride gas. What are you going to do? Here we are taught to calculate the mass. How do we find the mass? Mass is given by, look at our first formula. Our first formula is the number of moles is given by mass all over RFM. What about if we make mass the subject of the formula? If we make mass the subject of the formula, mass will be number of moles. Mass will be number of moles. Mass will be number of moles times RFM. Mass will be number of moles times RFM. Mass will be number of moles times RFM. So the number of moles are provided in the question, and the number of moles are 0.01. What about the RFM? The RFM is not provided in the question, but we can calculate, bearing in mind that the formula of hydrogen chloride gas is HCl. Hydrogen has an RFM of 1, then chlorine gas has got an RFM of 35.5. We get a total of 36.5. We get a total of 36.5. So 0.01 we multiply by 36.5. So after multiplying, the answer that you get should be in grams. So our online student, using your calculator, work out 0.01 times 36.5. The answer that you get, you give your answer in grams. You give your answer in grams. That's how we calculate the mass. That's how we calculate the mass. This is the general formula. Can you see the general formula of calculating the mass? The general formula of calculating the number of moles is given by mass all over RFM. What about the mass? Mass is given by the number of moles times RFM. Those are the formulas that should assist you solve those questions regarding interconversion of moles. Let's meet next time. Bye bye.